Hi there and welcome to the third video in this Euro 2021 data analysis series. We're going to look at data modelling in this video, and we're going to continue from the point that we left off in the last video, and that is to say we're going to take the scraped data that we had in the last video and we're going to convert these into an object-oriented viewpoint. We're going to create classes that model the Euro 2021 football data, and we're going to create two classes in particular: a result class that will hold the result with attributes for each team and the number of goals each team scored, as well as penalties and other information. And we're going to have a team stat class that will represent a team's overall statistics in the tournament. And these are things such as how many goals did the team score, how many did they concede, how many games did they win on penalties, how many games did they win, etc, etc. So let's get started. I have some imports here, and this is where we got to in the last video. We're collecting all of the result data into a results Python list, but these are just represented as strings that are returned from the show result function. Instead of strings, we want to now create a result object that will store the result in an object-oriented manner. We're going to see how to do that now. So let's start by just running all of these cells and collecting the data. This will take a while, so I'll resume the video when this completes. Okay, now that has finally completed. We can view the results, which is in a Python list, which will give us all of the result data, including the penalty winners, as we've seen at the end of the last video. So what we want to do now is we want to look at how to create an object that will model this data. So I'm going to paste in a bit of text here, just underneath. I'll remove the results array here and we'll paste in some text. And this will explain the process of what we're trying to do a bit more. So we're going to create a result class that models this data. Because currently we only have strings, we can't then query the string to say, well, who won the match or who lost the match. How many goals did the home team score, etc, etc. So this isn't strictly true that there is a home and an away team in the Euros, but we're going to model it that way anyway. Python, we're going to use the Python data classes in order to model this data. So there's going to be a result class with the following attributes. We're going to have the home team, we're going to have an away team, we're going to have the number of goals that the home and away team have scored, we're going to have an optional winner of penalties. If indeed the match went to penalties, then we'll specify who won that match with this property. And again, if the match went to penalties, we'll optionally have a penalty score, and this will default to none, as will the penalty winner, because obviously matches might not go to penalties. It's only knockout matches that can even go to penalties, so we might not have that information, but we want to model it anyway as optional. So as well as the properties, the attributes, we're going to have some helpful methods on the class. We're going to have an isDraw method, which will tell us, was this result a draw? We're going to have a winner and a loser method, which will tell us who won and lost the match. And we're also going to have methods to tell us how many goals were scored in the match total, and what was the margin of victory, what was the goal difference between the winning team and the losing team. So for example, the goal difference in a 4-1 victory would be 3. So let's get started with modelling that data. We're going to import from Python's Dataclasses module, which is available from, I think, Python 3.7. We'll import the data class, and this is actually a class decorator. And we're also going to import from the typing module. As I said, we have some optional attributes. So we'll import optional. And what we're going to do now is we're going to start creating our result class, and we'll decorate this with the data class decorator. So class result, and what we're going to do is we're going to start modeling the attributes on our class. So we'll have the home team, which will be a string. The away team will also be a string. The number of goals the home team scored will be an integer. And the away team goals will also be an integer. Now we come to the optional attributes, so penalty winner, that will be an optional string. This is the team who won the match in penalties, which will default to none. and the penalty score will be an optional string in this case, just for simplicity. That will also default to none. So that's the attributes on the class. We're now going to start modeling some of the methods. So we'll start with the isDraw method, and that takes self as a parameter, like all Python instance methods, and it will return a boolean because it's a true or false value. Was the match a draw or not? Now, we could simply say that the match is a draw if the two teams scored the same number of goals, but because of the penalties, that becomes a bit more complicated. But let's first of all check if it was a score draw, and that's a very simple check. We say, was the home goals and the away goals equal? So did the home team and the away team score the same number of goals? And if they are equal, that will evaluate to true. And if it was a score draw, we can then check whether the penalty winner is none. If the penalty winner is none and it was a draw, then we know we're dealing with a group match, not a knockout match, and we can say that yes, that was a draw. If the penalty winner is not none, we know that the match is a knockout match and there was a winner, because knockout matches by their nature cannot end in a draw. So we can check whether or not it was a knockout match, or let's say whether or not it was a group match, by saying self.penalty winner is none, and the condition for it being a draw is that it's a score draw and it is a group match, because knockout matches cannot be draws. There has to be a winner on penalties. So if the penalty winner attribute is none and it's a score draw, we can say that the match itself, the result, was a draw. So that's the logic for that method. And let's now move on to the isWinner method, which is again taking self, and this will return an optional string. It's optional because if the match is a draw, this is going to return none. It's not going to return an actual string value, but if the match has a winner, then it will return the name of the team that has won the match, which will be a string. And we'll start by checking if the match was a draw. So we'll call the self.isDraw function, and if that returns true, the match was a draw, so there was no winner, we're going to return none. Otherwise, if the match was not a draw, we're going to implement the logic to find who won the match. It's going to be very simple. If the home goals is less than the away goals, if the home team have scored less than the away team, then we will return that the winner is the away team. So it'll be self.away, which will represent the name of the away team. And on the other hand, we can say if the away team's goals are less than the home team's goals, then we will return the home team, because the home team have won that match. And finally, we can chain an else condition to the end of this, where if it's not a draw and the number of goals each team have scored are equal, then that means that the winner must have been on penalties. So we can then return the self.penalty winner, which represents the name of the team that won on penalties. So that completes the winner function. And the loser function is going to be fairly similar. So we'll define that now, and again that will return an optional string. And the name of this function shouldn't be isWinner, it should actually be just winner, because we're returning the name of the winner, it's not a boolean. So the loser function, what we're going to do is, again, we'll check whether or not the match was a draw, and then we can copy these conditions. And if the home goals is less than the away goals, we will return the home team because they lost that match. And if the away goals is less than the home goals, we can return the away team because they lost that match. And again, we'll chain an else condition here to say if the number of goals is equal but it wasn't a draw, we're going to return the team that did not win in penalties. So we'll change this part of the code here, and we're going to return a conditional expression. If you don't know what those are, there is a video that I've made that I'll link to in the description, but basically it's like a ternary operator. We return the home team if the penalty winner is the away team. Otherwise, we will just return the away team. Now let's go through this quickly. We know that if we get to this block, there is a match has gone to penalties. So if the penalty winner is the away team, we want to say that the loser is the home team, so that's what we return. Otherwise, we will return the away team. So that's the logic there. There are two more functions I'd like to quickly define here, and that's the goals scored. And this is a simple function that will tell us how many goals were scored in the match, and that will return an integer. And this is a simple addition operation. We take the home goals and we add the away goals, and that's the number of goals scored in that match. Very simple. And the goal difference, again, will return an integer here. We've got two teams, and what we want to do is we want to return, let's say, the home goals minus the away goals. Now there is a situation here where you can imagine it's 4-1, this would return 3. However, we also want to cover the case where maybe it was 1-4, the away team scored 4 goals. So if we did the subtraction here, it would be -3. So we're actually going to take the absolute value of the difference, and that will give us the goal difference for the match. And that's all for the normal methods. I want to define one quick dunder method called the dunder contains method. And basically we want to say, does this result contain a given team? Well, we would provide that team as a parameter, and that's going to return a boolean, and we're simply going to say the team is in self.home and self.away. So that'll allow us to say, for example, Italy in fixture, or Italy in result, and it will return true or false based on whether one of the teams is Italy. So that's just a handy contains dunder method. And the final dunder method, I'm just going to copy paste in here. It's similar to the function we defined in the last video for printing out the stringified version of the fixture. It's going to be the home team, the number of goals the home team scored, and then a dash, and the away team's goals and the away team's name. So that's going to be the string method, and that completes our result class. We're now going to modify the loop where we collect the data in order to, instead of saving them as strings, we're going to save the results as these objects with the correct properties. But before we can do that, we need to take care of one thing, and that's the penalties. Penalties at the moment are represented as strings. Let's have a look at this. I'm going to paste some text in here that will help us understand this problem. So yeah, let's have a look at the penalty data. We need to extract the team that wins the penalties. Now if we look up at the results array that we had, I'll just redefine that here. If we look at the results, you see that the team that won on penalties is represented by this string. For example, Switzerland win 5-4 on penalties. So we need to extract from that string the team that have won. So what we need to do is get the team name and get the penalty score, which we also have as a field in the model. So for example, the team name would be Switzerland, and the penalty score in this case would be 5-4. I don't think it was that in the real game, but you get what I mean. So we need to write some code that will extract the team name from this string, and it will also extract the score, the numerical score of the penalties from the string as well. So what we're going to do for the team name is we can simply split on the spaces and return the first element. So if you look at that sort of string there, we split on a space, and the very first element in the resulting list will be the team name. Now for the score, we're going to use the regular expression module in Python to find the following pattern. We're going to find a digit followed by a dash followed by another digit, and that's basically what would capture this expression here. We've got a digit in 5, then we've got a dash, and then we've got another digit 4 that gets the other team's penalty score. So let's write some code. We're going to use the RE module for the regular expressions in Python, and let's work with a dummy message that I'm going to paste in here, and it's team name, just random team name, win 5-4 on penalties. So let's say Italy, and let's now try and get the team name. So we'll get the team name first by saying the winner equals, and we'll split the message on the space, and we'll get the very first value from that. And if we look at that, we should see that that is Italy. So we've successfully extracted the team name from that string. Now we want to try and get the penalty score from the string as well. So what I'm going to do is use the RE module, and we'll define a search over that string. And the pattern is a digit, one digit, followed by a dash, followed by another digit. And we apply that to the message, which is the string. And if we do that, we can print that out there, and we get a match object. And we see that the match captures characters 10 to 13, and that corresponds to 5, 4. So this regular expression looks for a digit, it looks for a dash, and then it looks for another digit, and we can get the penalty score from that regular expression. And we're going to use this to extract the penalty winner and the penalty score for our result class. So let's get started with the code now for redefining our loop. We again have a results array, but this time the results is going to store result objects, not strings. Okay, so for URL and URLs, and I'm just going to copy some of the code we used before, basically get down to the point where we have penalties. Yeah, so let me paste this code in. We'll go over it again. So response equals request.get URL. We sleep for a second. We pass our text from the response to the BeautifulSoup object, and then we can use BeautifulSoup's constructs such as find all to get what we need from the actual HTML document. We get the home, away, the home goals, the away goals. We extract that. And then if the game date is greater than or equal to the knockout game's start, we can then try and get the penalties. Now, if the penalties is not done, this is where we're going to start using our regular expression. We're going to extract the winner, writing similar code as we did above. So the penalty winner will be equal to, it's going to be equal to the text within the penalties element there. That's a BeautifulSoup thing. We get the element and then we get the text within the element with that class. And then once we've got the text, we can split on the space and get the first element. Remember that this text will correspond to a string of the form like that. So when we split on the space and get the first element, that will give us the team as 1. And similarly, to get the penalty score, we will copy our regular expression from above and paste that in here. And instead of message, we will refer to the penalties text. And to actually get the penalty score from the search, we can call the .group function on that. And just to show you what that does, we call .group up here. If we look at the regular expression search, we get back a match object, but to get the actual text that we're interested in, which is the 5-4, we call .group, and that gives us that back as a string. So we call .group on that and we get the penalty score. The next step is to create the result objects from this data. So I'm going to say, in this case where we've got penalties, results.append. Results of course refers to this list here. We're appending, and this is where it will change from the previous example. We're now appending result objects. So we'll instantiate a result object, and I'm going to pass the data in, home, away, and then we'll take the home goals that we captured up here. This by default is a string, so we'll convert it to an integer, and the same for the away goals. And this is the block where we have penalty winners and penalty score. So the penalty winner will be equal to that, and the penalty score will be equal to that. So we've modeled this data and captured what the values are on the web page, and now we create a result object based on that. And in the case where the game has not went to penalties, we can do something similar. I'm going to copy some of this code here. We don't have the penalty stuff, but we have everything else. We instantiate a result object, and let me just try and clean this up a bit. We instantiate a result object, and we pass the home, the away, the home goals and the away goals to that object. And that's pretty much all the code we need. We do need to continue in the case where we find that there are penalties. we want to continue the for loop once we've appended the result rather than go down to this block here. This should only be run if this particular block isn't run. We could actually wrap that in an else condition, but it works fine as it is. So we add the continue and then I'll execute that code. This will take quite a while, so we'll join up again after this completes. And now that that's completed, we can take a look at the results that we've got. This should now be slightly different from before. We don't have strings, now we've got result objects with home teams, home and away goals, and we also have penalty winners and scores. And if we go down to some of the knockout games, we can see the penalty winner, for example, in the final. The penalty winner is Italy. Penalty score was 3-2 in that final. So we're now modelling the data and we have some useful attributes on these objects, and we can also call the methods on the objects, as we're going to see soon. So yeah, this is a more useful representation than it was before when it was just a string. Let's see some of the things we can do with that now. So for example, I can look at the first element of the results, and that will give us a particular result, and we can say call the winner function, and that will give us back the winner, which was Italy. And of course the loser function will give us back Turkey, who lost that match. The isDraw method, that will give us back false because there was a winner in this match. And if we look at the goals scored method, we get 3 because it was 3-0 to Italy. And of course the goal difference was another method that we defined, and this will also be 3 because it was 3-0. I think it was goal difference. Yeah, 3. So we're now able to call these methods and find out information about the result, which is something you cannot do with the raw string. Let's now look at the winners, and we're going to use a list comprehension here. So I'm going to call for each result, for our own results, we'll call the winner method to get the winner for our own results, and let's see what that gives us back. We just print out the winners here. And we get Italy, we get none. Now the nones are because the match was a draw, so we can chain an if statement here if the match is not a draw. So if not r.isDraw, that will get rid of the nones, and then we get back all the teams that have won matches. And now you can actually perform useful analytics here. So what I can do is, for example, I can import from the collections module the counter object, and this is just a taste of the next video where we're going to really look into this stuff in a bit more detail. But we could evaluate the winners with the counter object, and then we could say counter.most common, let's say the 3 most common. That will give us the 3 teams that won the most matches at the Euros. So now we have Italy, who won 7 matches, England won 5, and Belgium won 4. So very useful functionality here. And I could do the same for the losers. Let's see who lost the most matches. So yep, we'll call counter on the losers and we'll see who's the most common. Turkey, Denmark and North Macedonia, these are teams that lost the most matches at the tournament. So we're performing useful analytics, and we're going to see more of that in the next video. And in the rest of this video we're just going to have a look at some useful basic stats from the data. So for example, we might want to say, you know, we've seen the winners and the losers, but we might want to see which games ended in a draw. So we can use our list comprehension. For each r in results, we want to return r if r.isDraw, and that will give us all the games that were a draw. And from that we get back the results here, and if we call the stringified version, we'll get a more accurate, sort of human friendly way to look at the result. These are the games that ended in draws in the tournament, and if we wanted to find out how many games were draws, all we need to do from that is call the len function, and we can get that information. So there's lots of useful analytics we can do here. We've got functions on our result model to do that. For example, we can calculate the total number of goals scored in the tournament. So let's define a list comprehension. For each result r, we're going to call the goals scored method, and that will give us the total number of goals scored in that match. And then what we need to do is just call the sum method that's a built-in method in Python, and sum up all the total goals. So that gives us 142 goals scored in the tournament. So all we're doing here, this gives us the number of home goals plus the number of away goals in a given game, and we get them for all, we get those numbers for every result in the tournament, and then we call sum on the resulting list to get back an integer. 142 goals scored. And we can also look to find the game with the maximum goal difference. In other words, which game had the biggest margin of victory. So I'll call max goal difference, and that's equal to, we'll call the max on r dot goal difference for r in results. So for every result we're calling goal difference to get the margin of victory, and then we apply the max function to that to get the maximum. So if I just copy that, we can see what the maximum was, and the maximum margin of victory was 5. To find out which game that was in, we can, let's just do another list comprehension. So r for r in results, if r dot goal difference equals, we'll say max goal difference, and that will give us back the game with that particular result. So we'll say biggest victory, and if we print that out, you'll get the match. It's Slovakia versus Spain. So if we stringify the result, we'll find out who actually won that match. It was 5-0 to Spain, and that's calling the dunder string method when we do that. So the biggest margin of victory in the tournament was Spain's 5-0 victory over Slovakia. So that's quite interesting, and there's lots more you can do, but for now we're going to do most of the analytics in an upcoming video. In the next video we're going to take a look at team models. We're going to have a model for team statistics, such as how many goals did Italy score versus England, how many goals did each team concede, what was the tournament goal difference, how many games went to penalties, and so on. We're going to cover that in the next video. It's going to be another data class that we're going to define, and we're going to remodel some of the data. So stick around for that. Thank you very much for watching this video. There's a comprehensive GitHub notebook on GitHub, and there's also a blog post that goes into this in more detail. Do check those out. Do like and subscribe if you've enjoyed the video, and thank you for watching.